Welcome back, students. So in this video we are continuing another problem of Bayes rule. Okay, so I will narrate the problem first and then I will provide the solution. 1% population of a city is HIV positive. A machine can test people for HIV positive. Machine reports HIV positive with a probability of 0.9 if a person is HIV positive. It also reports HIV positive with a probability of 0.05 if a person is not HIV positive. A random person is in the city is tested and machine reports HIV positive. What is the probability that the person is actually HIV positive? So after reading the question, first you have to interpret the problem and you have to visualize the problem in your mind. So I will help you in that. So in this question, there is a population and 1% of that population is HIV positive. And we can take a random person and test him using a machine. And that machine is not 100% accurate. It can give a result HIV positive in both the cases. The cases are a person is actually HIV positive, another case is that person is not HIV positive. Even in that case, machine can declare that it's HIV positive. So the question here is, given that machine declares that HIV positive is there, what is the probability that person is actually HIV positive? So in these kind of problems, as I told you in last video and last lectures, that the crux of the problem is to develop the probability expression which you have to find. That means identifying the events. Here, if I say that H is the event that a person is HIV positive, okay, then pH is how much? pH will be 0.01 because 1% of population is HIV positive. That means if you assume that H is an event, a person is HIV positive, then probability that a random person selected from the population is HIV positive will be having probability of 0.01. Okay? But the population also has people who are not HIV positive. So another event H bar we can write as a person, of course a randomly selected person, is not HIV positive. Okay? So pH bar will be how much? pH bar will be 0.99. Okay? pH bar will be 0.99. That means person is not HIV positive. Now, these are the events H and H bar. A person is HIV positive and a person is not HIV positive. In the last videos, I told you that one important step in these problems will be to identify the main event. Main event means the event which happens with many other events. So now which event happens with these events? H and H bar. That event is machine declaring HIV positive. So let's assume that the event is A. And A is the event that machine reports HIV positive. So this is the main event, okay? And A can happen with H and A can happen with H bar. If a person is HIV positive, then machine can report HIV positive. If the person is not HIV positive, even then machine can report HIV positive. Okay? So now you have to think of the expression, probability expression which you have to calculate. Okay? So what do you have to find basically? We have to find P of H given A. That means, given that machine reports HIV positive, what is the probability a person has actually HIV positive? Okay? So P of H given A we have to find here. Okay? What is the probability that the person is actually HIV positive given that a random person selected and machine has reported HIV positive? So this will be equal to P of H intersection A upon PA. We have done so many times. in the previous videos also, okay? Now P of H intersection A will be P of H into P of A given H, okay? And P of A can happen with H and H bar, okay? Now P of H into P of A given H will be numerator as usual, and this will be equal to, again copy the same thing, P of H into P of A given H plus P of H bar into P of A given H bar, okay? Now we can start writing the numbers here. PH means probability that a randomly selected person is HIV positive, 0.01 because 1%. Okay. P of A given H. Given that a person is HIV positive, what is the probability that machine reports positive? That is 0.9. Machine reports positive with a probability of 0.9 if a person is HIV positive. 0.9 plus. Sorry, no plus because there is only one expression. Now, denominator. We can just copy the same thing here. Yes. Okay. pH bar. That means probability that a randomly selected person is not HIV positive. 0.99. And P of A given H bar. Given that a person is not HIV positive, what is the probability that machine reports positive? And this probability is here. It also reports HIV positive with a probability of 0.05 if a person is not HIV positive. So 0.05. Okay. That number I will calculate by calculator. Okay. So that is 2 by 20. Okay. So I hope now you are very clear about how to calculate probabilities for problems involving Bayes rule, total probability, conditional probability, and so on. So from the next video onwards, we will start random variable and probability distribution. I hope you are enjoying the videos. If you have any doubts, comments, suggestions, please write at the bottom of the video. We will take care of that as soon as possible and do the needful. Thank you so much. Please subscribe our channel, like our video, and share the video. Thank you so much.